We are looking today at how we can use trigonometry to help us discover what maybe a side of a triangle is equal to. Remember, we specifically are looking at right-angled triangles at the moment. Trigonometry can find out angles of non-right-angled triangles, but that isn't where we're at yet. So specifically looking at right-angled triangles. At the moment, we have learnt our word sokatoa. You might want to remember it as some old hens cackle and howl till old age. Now, each of those actually has a very specific meaning. Remember, the S stands for sine of theta. So sine of the angle is equal to the opposite divided by the hypotenuse. Cos or cosine of the angle is equal to the adjacent divided by the hypotenuse, and tangent of the angle is equal to the opposite divided by the hypotenuse. So you just need to remember the initials, and hopefully you'll remember those words. It is very important though that you remember how to label them. If this is my angle, if I've been given theta, my opposite angle is exactly opposite that angle. Adjacent means next to, and it's next to theta, and hypotenuse is always the side that's opposite the right angle. It's the longest side. Now, when I have my triangles, what I first of all need to do is label all my sides given my angles over there. So this is the angle I was given, so the opposite angle is exactly opposite. So I'm going to put an O there. This angle is my adjacent because it's right next to it, and this long one, AC, is my hypotenuse. So once I've labeled those, I can then think, what am I trying to find? I'm trying to find X over here. What have I got? I've got my hypotenuse. I'm not trying to find this, and I don't have any information there, so I don't have to worry about that. So O and H are the two sides that I am going to want to use. Which of my three trig ratios have O and H in? Well, the only one that I can see is my sine. My sine is equal to the opposite divided by the hypotenuse. So sine of the angle, which is 30 degrees, is equal to the opposite side, which is x, divided by the hypotenuse, which is 12. Now what I need to do is rearrange that. So I need to look at, if this was algebra, this whole thing is one thing. Sine of the angle is one thing. So I need to times that by 12 so that I'm not dividing by 12 anymore. If I times my right-hand side by 12, I need to times that side by 12 as well. So 12 sine 30 equals x. Then you get your trusty calculator out. You do have to use your calculator at the moment, and just type in 12 sine 30 degrees, and you will see that it is equal to 6. And they've given us the units in there, so I know that x is 6 centimeters. What I'd like you to do is first of all have a look at 2, 3, and 4 and see if you can label the opposite, adjacent, and hypotenuse on each of those triangles. Pause it, do that, and then come back. So I'm obviously not pausing, I'm just carrying on. I'm looking at 72, so my opposite side to that, opposite is over there, my adjacent is over there, and that's my hypotenuse. In 3, my opposite is over there, my hypotenuse is over there, and my adjacent next to is over there. And this one, my opposite, adjacent, and hypotenuse. So I hope you got all of those right. Now what I want you to do is think of which ratio you're going to use. In this triangle, we don't need to worry about H because it hasn't been given and we're not trying to find it. So I'm looking for the ratio that uses opposite and adjacent. And if I look at my ratios, I will see that it's wow, that was annoying. It is my tan. So tan of 72 degrees is equal to the opposite side opposite side, which is my x that I don't know, and adjacent is 15. So tan of 72 is equal to that. Now I'm dividing by 15 here, so I need to do some algebra to get rid of my 15, and 15 tan of 72 equals 46.17. Again, it's in centimeters, so put your units in. I will leave you to do the other two, and I will check that in class tomorrow. Thank you for watching.